Good morning, everybody. I hope you guys are doing well. Today I'm going to be looking at exponents, discussing some theory, how it works, just so you can understand it a bit better. And we're going to look at a few easy examples. So this is just basics, just so you guys can figure out what's really going on. Okay, so let's go have a look at some basic things you already know. You know that 2 times 2 is equal to 4. And a while back, I told you guys that we will be doing this. And that's also equal to 4 to the power of 2. Now, that to the power of 2 is also saying 4 squared. It's the exact same meaning. Okay, 4 squared. Now, if we take this and we do the inverse operation, remember inverse means opposite operation, we can say that the square root of 4 will be 2. Let's go have a look at another one. 3 times 3 is equal to 9. Another way of writing it using exponents will be to say 3 to the power of 2 is the same as 9. Once again, we're looking at that 2, this time meaning 3 squared. And this 2 basically just tells us how many times am I going to times the number by itself. That's what that little 2 refers to, the exponent. How many times am I going to time the number by itself? Then if we look at the inverse operation, which would be the square root. So once again, you have the square root. The square root of 9. Square root of 9 will be equal to 3. If you take it the other way around. All right. Now we're going to go and we're going to look at a few more examples just to get into it and so that you can get used to how it works. So we're going to continue. 4 times 4 is equal to 16, and we can also write it as 4 to the power of 2, or 4 squared. Then we can say that the square root of 16 will be 4. 5 times 5 is equal to 25, which is the same as 5 squared. Inverse operation, square root of 25 is equal to 5. So now what I want you guys to remember is that it's always good to know where it comes from, just so that you have a better understanding of why it works like it does. Now, if we have a square and we say that each of the sides are 6 units. Remember, it's a square. With a square, all my sides are equal. What do I do? To get the area. Area refers to the space inside. I would say 6 times 6, and 6 times 6 will give me 36 in a square. So 6 squared is equal, 6 in a square is equal 36. And the square root of 36 will be equal to 6. Let's go look at another one. Again, I'm going to use a square. 7 and a 7. Remember, a square, all sides are equal. How do I know what the inside is? I'll say 7 times 7, which is equal to 49. And this is also the same as 7 squared, the 49. So the square root of 49 will be 7. So with this, we can see that square numbers, which are these, our squared numbers, and our square roots are inverse operations. So now I want to show you guys something that you need to start knowing now, because as we continue, you will be expected to answer questions similar to this one. So let's say I have the square root of 124 squared. How would I go and calculate that? Remember, I just told you that they are inverse operations. Inverse, opposites. They cancel each other out. So the answer for this question will be 124. I don't have to go and calculate what 124 times 124 is and then try and get the square root. It's going to take you forever. You know already that the square number and the square root are inverse operations. So they cancel each other out and you are left with 24. I'm going to prove that to you using an example we've already done. We already said that 5 squared is equal to 25. Yes, because 5 times 5 is 25. So the square root of 25 will be equal to 5. But if 5 squared and 25 is equal to each other, we can say that the square root of 5 squared will be equal to 5, because 25 and 5 squared is equal to each other. So what happened over here? The exact same thing that happened in the previous example. The square number and the square root cancelled each other out, and we were left with a 5. Alright. Next I'm going to take you guys through cube numbers. So if square numbers refers to squares, what do cube numbers refer to? Cubes. So let's say here's a cube, not the best one ever, but you get the idea. Remember, with a cube, again, all the sides are equal. So now, let's say the length is 4, the breadth is 4, meaning the height would be 4 as well. And if you have to calculate the volume, because for 3D objects, the inside, the total amount of space it takes up is our volume, we will say length times breadth times height. So it will be 4 times 4 times 4. And 4 times 4 times 4 can also be written as 4 to the power of 3. 4 cubed. Because that 3 means it's cubed. It's the number itself multiplied by itself 3 times. So let's go have a look at another one. Again, I'm going to just do a little cube. And this time I'm going to tell you that it is 5. So that means 5 times 5 times 5, because it's length times breadth times height, will be the same as 5 cubed, because it's in a cube. So the total number of blocks will be 5 cubed. So let's go work that out. 5 times 5 is 25. And 25 times 5 is 125. So now let's do the inverse. The inverse of a cube number is a cube root. Once again, you have your root sign, but this time there's a little 3 because it presents the cube. So the cube root of 125 will be 5. Inverse operations, opposites of each other. So in the previous one I did a 4, just to illustrate the cube to you. So let's go look at that. 4 to the power of 3, 4 to the power of 3 means the same as 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. So now let's take it back. The cubic root of 64, inverse operation, so the answer will be 4. There's my 4, there's my 64. There's my 64, there's my 4. Inverse operations. I'm going to show you guys the same thing I did as with the square numbers. Let's say I have the cube root of 203 cubed. For you to work out 203 cubed, you have to say 203 times 203 times 203. Once again, it's going to take you forever, and then to go back again, it doesn't make sense to do it that way. You know that cube numbers and cube roots are inverse operations. So there's my cube root, there's my cube number. They're inverse, they're opposites, they will cancel each other out. So the cube root of 203 will be 203. Let's go see one that's pretty easier. 2 times 2 times 2 can be written as 2 cubed. 2 times 2 times 2 is also equal to 8. So the cube root of 8 is 2, because they are inverse operations. So if I say the cube root of 2 cubed, and 2 cubed and 8 is exactly the same number, my answer will be 2, because they cancel each other out. Okay, that's basic square numbers and cube numbers. The last thing that I just quickly want to do in the video is just exponents in general. And then in the next video, we'll do calculations with exponents and roots. Okay, this is just a basic one. So let's go have a look. If I have 5 to the power of 4, what does that mean? That means I have to take 5 and times it by itself 4 times. So it's 5 times 5 times 5 times 5. That's what it means. If I have 10 to the power of 8, it means I have to take 10 and times it by itself 8 times. So I will have 10 times 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 10. Let me show you a little trick with numbers. Well, they call it power of 10 numbers. 10 to the power of 1 means 10 times itself 1 time. So it's just a 10. 10 to the power of 2 means 10 times 10. 10 times 10 is 100. 10 to the power of 3 means 10 times 10 times 10, and that's equal to 1,000. Now if you go look, what do you notice? What do you notice about the tens? You should notice that to the power of 1 has 1 0. To the power of 2, 2 zeros. To the power of 3, 3 zeros. So how many zeros will I have when it's 10 to the power of 8? I will have 8 zeros. And that'll be the answer if an answer is required. All right. Basic exponents, square numbers, square roots, cube numbers, cube roots, and then this, writing it in expanded notation, is just the basis of what you need to know. You have to go and study at least the first 12. That means like your timetables. Same way you will do here. You'll say 2 to the power of 1 is 2. 3 to the power of 1 is 3. Do you guys see? Because it's only 1. Remember that. Because lots of times you guys forget that that 1 basically just refers to the number itself. Then you're going to go on to square numbers. 2 to the power of 2 is 4. 3 to the power of 2 is 9. 4 to the power of 2 is 16. And continue, continue, continue until you get 12 to the power of 2, which is 1. 44. Square numbers, you need to know them off by heart. Don't forget about their inverse. Square root of 4 will give you 2. Square root of 9 will give you 3. Square root of 16 will give you 4. So the square root of 144 will give you 12. Same goes for cube roots and cube numbers. Normally the ones that you need to know off by heart, so that you don't have to go into a test and sit and calculate your times and go crazy, just know them off by heart, then the test will go much quicker. So once again, you'll say 2 to the power of 3, which is 2 times 2 times 2, so that's equal to 8. 3 to the power of 3, which is 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is 27. 4 to the power of 3, we've done 64. One that's asked often is your 10 to the power of 3, because it's one of the most basic ones, which would be 1,000. Remember I said the total in the exponent tells you the total of zeros when you have powers of 10. Once again, you go and do the inverse, and you'll say the cubic root of 8 is 2. The cubic root of 27 is 3. The cubic root of 64 is 4. The cubic root of 1,000 is 10. I want to show you guys something. What is the square root of 64? Not 4. Square root will be 8. Why? Because 8 times 8 is 64. But the cube root of 64 is 4. Why? Because 4 times 4 times 4 is 64. Okay. I'm going to end with that. I hope it makes a little bit more sense, and I hope you guys will go and practice and you did the examples with me. I will be posting more of these recordings. I know it's not the best, but at least it's something. And please, you guys are allowed to ask questions, math-related questions if you don't understand something. Read your instructions. All the videos are on the classroom. All the worksheets are on there. Most of the memos are available. Go and work hard. This is your time to prove that you can be a responsible learner. Okay, see you guys in the next video. Well, you'll see me.